Hi, I'm Luke Kimes.
Hello, I'm Elias Alvarez.
And I'm Tanai Shah.
Today we're going to be showing you our project, machine learning based log analysis for SQL injection detection. So just an introduction, SQL injection attacks remain a significant threat to web applications and are often exploited by attackers to manipulate database and exfiltrate sensitive information from companies. Access to web development resources is prevalent to users of all experience levels. As programming languages create more web frameworks, companies hire more web developers, and AI is utilized to write these applications, the lack of web security becomes more apparent in the world. Detecting SQL injection attacks on your application can be difficult to detect and requires an understanding of how the SQL language works, which many users lack. However, machine learning can be used to support the detection of SQL injection attacks by training a classifier to achieve the ability to recognize and therefore detect an attack, which is what we aim to do. Our mission is to utilize modern ML technology to detect SQL injection class exploit attempts within website access logs and highlight those attempts to the user. Further implementations of the ML project has potential to be used to catch SQL injection exploits before they are able to execute. Such technology may also aid in the detection of zero-day exploits that make use of SQL injection. And we seek to demonstrate the feasibility of ML algorithms for modern detection and to prove their malleability or other classes of web exploits that share similar characteristics. So this project uses a machine learning-based approach to web and log analysis to classify those SQL queries as either benign or malicious, aimed at improving the detection of web-based threats. These SQL queries are going to undergo a cleaning process where irrelevant data will be removed. So to begin to send data to our model, we first need to clean it. Depending on the scenario, our project will either be fed queries from access logs or from the web application itself. Once queries are passed to us, our application will note down specifics of the query, such as the presence of certain SQL operators or query characters common in malicious attacks. The SQL queries and their metadata will be fed into a machine learning model specifically trained to detect SQL injection attacks. The model will classify each query as either benign or malicious based on features such as query structure, keywords, and behavior patterns typically associated with SQL injections. This approach will help identify the potential security threats encountered by our given application. Queries identified as malicious by the program will invoke a response that indicates as such. From here, a user may distinctly see whether or not a given query is considered to be safe. And in the future, if integrated with the application, execution of the malicious query could be avoided altogether. Security professionals may be able to use this new insight to identify malicious behavior and further incident response investigations.
All right, let's talk a little bit about the materials and methods here. So the first step in any machine learning project is data collection. We'll be utilizing an open source SQL dataset from Kaggle. This contains a labeled series of SQL queries that are labeled benign or malicious, and we'll use this for training purposes. The next step is actually training the ML model. So ML will be trained using the dataset mentioned above, and we'll enrich it with additional columns, such as columns for the presence of comment characters and other SQL verbs. We'll do this to help the ML make its determinations. The final step is web log classification. So the core of the system is the machine learning model that processes web logs and classifies SQL queries as either benign or malicious. Logs classified as malicious will be flagged for further analysis by security professionals. All right, so what does this all look like? Let's look at an example for line-by-line log parsing. So we'll take logs from an access log, for example. We'll determine if there's a SQL query present. If there isn't, we'll mark this and move on. If there is, we'll isolate the query, note down any red flags such as specific keywords associated with SQL injection, and then send the query and the keywords over to the machine learning model. The model will then make its determination whether a query looks like SQL injection or whether it doesn't. It'll then save the line number and return the final output to the user. What does this look like practically? Let's take the example of the classic SQL injection, admin or 1 equals 1. We'll identify this as a SQL query. We'll then isolate the query, note down red flags, such as the presence of the single backtick or the pound character. We'll then forward this query and the keywords to the machine learning model, which will then make its determinations. It'll hopefully output that, yes, this is in fact SQL injection, and return the output to the user.
All right. So for our expected results, first off, we would like to achieve a high accuracy in classification by using machine learning model to classify SQL queries. The system will minimize false positives and false negatives, leading to better detection of potential web threats. Next, we would like to see improved analyst efficiency by providing classification results and highlighting lines of logs flagged as malicious. The system will reduce the manual effort required by security professionals to interpret raw log data, improving their ability to respond to threats quickly and effectively. Next, you want to see scalability for future web attacks. The system should be flexible enough to expand its classification capabilities to recognize additional OWASP top 10 vulnerabilities and other emerging web attacks with the addition of new machine learning modules. We would also like to see user-friendly output. The classified results will be displayed in a straightforward format, making it easy for security professionals to see which logs were determined to be malicious without the need for complex interpretation. Here we have figure 3, where it describes the user submitting logs to the user interface. On the threat analysis side, the web logs will be received. It will identify and isolate SQL queries, identify substrings commonly associated with SQL injection. The machine learning will determine malicious or benign logs. It will highlight lines containing malicious SQL queries and return the results to the user with the malicious lines highlighted. Thank you.
Thank you.